Mangaroos Tutoring Services, Mathematics Classes.
Algebra. We will begin with a definition. What is algebra? Algebra is the manipulation of algebraic terms according to the rules of arithmetic. An algebraic term is a symbol such as a letter which represents a number. So I will give a simple example. If we have x plus 5 equals 7, we can deduce that x is equal to 2 because 2 plus 5 equals 7. I will give another example. Three multiply, if we have an asterisk, equal 15, then we can solve this to be 3 times 5 is equal to 15. So we know that the asterisk is equal to 5. So we can use any letter or symbol as an algebraic term. Next, we are going to do some addition and subtraction of algebraic terms. In order for us to add and subtract terms, they must be like terms. So for example, we cannot add and subtract x and y. So what do I mean by that? If I have x plus y, I cannot say that this is 2x or 2y or 2xy. If we have x plus x, we can get, or we will get 2x. If we have y plus y squared, these two terms are considered different because one is y and one is y squared. So your answer will not be y cubed. If we have y squared plus y squared, this will give us 2y squared. So each term will be different if it have a different indice or a different letter or symbol. Okay, so let's take a look at adding and subtracting. So we can simplify the expression or equation before we solve. Simplification is the reduction of the amount of terms by various means which include addition and subtraction of like terms, factorization, and rules of indices. Like terms are terms that have the exact same variable, including the value of the index, or as we saw before, the indices or the powers. Unlike terms do not have the same variable. Only like terms can be combined through addition and subtraction. So here we have a few examples. So constants, we can add constants. 4 plus 7 is 11, 12 minus 6 is 6. Like terms, we can add these or subtract these. 12ab minus 3ab is equal to, so if the terms are the same, AB and AB, we can simply do your regular arithmetic with your numbers. 12 minus 3 is 9, and put back the term. 4x cannot be added to 3x squared because x is considered a different term to x squared. These two can be added, but this one can be subtracted. And these three cannot be reduced or simplified or added and subtracted. So you can feel free to pause the video and take this note down. So let's try these questions. This exercise is simple. All of the terms, as you will realize, are like terms, so it's just a matter of adding and subtracting. So you can pause the video now and attempt these. Let's go to the answers. Five plus 1 is 6. 6 minus 3 is 3, so that's 3x. 2 minus 15 is minus 13. Minus 13 plus 12 is minus 1, so that's minus 1a. 3y, a minus by a minus, or a minus and a minus combined will give you an addition sign because the signs are adjacent. So that's 3y plus 4y is equal to 7y. 2 minus 3 is minus 1, so that's minus 1ab. 7 minus 12 is minus 5. Minus 5 plus 5 is 0. 9 minus 16 is minus 7, so that's minus 7m. Minus 14 plus 13 is minus 1. Minus 1 plus 2 is 1. And they are all in terms of n. 12 plus 13 is 25. 25 minus 7 is 18, so that's 18p. 2 minus 9 is minus 7, so that's minus 7xy. And minus 5 plus 1 is minus 4, so that's minus 4ab. So let's try another exercise. This exercise may have terms that are different. Some of the terms may not be able to be added or subtracted. So pay close attention. So pause the video and attempt these. Three minus 5 is minus 2. Minus 2 plus 7 is 5, so that's 5a. Number 2 is straightforward. Number 3 is straightforward. Number 4 is simple. Number 5 is simple. Right, so number 6. We have an expression in terms of x, one in terms of y, and one in terms of xy. So we cannot add these three because they are different terms. It's already in its simplest form. AB is different from A, which is different to B. So these two are similar, AB and AB. So 8AB plus 4AB, that will be 12AB, and then we put back these two terms. Similarly, for number 8, we cannot express this in any simpler way, or we cannot add or subtract them. Right, this is called a quadratic expression, by the way. A squared is different from B squared, which is different from AB, which is different from a constant. So we cannot simplify further. Right, so number 10, we have B and B. So minus 12 minus 14 is minus 26. So that's minus 26B plus 3. So let's move on. Let's see if we have, right, let's move on to multiplication of algebraic terms. So here we have a few examples. So we should know our multiplication before we begin this exercise or this subtopic. Make sure you know how to multiply and divide your directed numbers. So make sure you know all your rules. You know a positive number by a negative number is equal to a negative number. A negative number multiplied by a negative number is equal to a positive number. A negative number multiplied by a positive number is equal to a negative number. So let's take a look at number 1. 6 multiplied by 3 is 18. A positive number multiplied by a negative number is a negative number. A by A is A squared. And then we have B. So you can multiply signs, then numbers, then letters. So this one will be positive by positive is positive. 4 by 3 is 12. And x by y is xy. Negative by negative is positive. 8 times 5 is 40. So that's 40 AB. So let's try these. So unpause the video when you are ready to begin correcting. Number 1. Minus 3 by positive 12 will give you negative 36. X by x will give you x squared. That's x squared y. 4 by AB will give you 4AB. Negative by positive will give you negative. 5 by 5 is 25. X by y is xy. So let's put the answers here. Positive by negative is negative, so that's 6 by 2 is 12, so that's negative 12 AB. So this will be minus 60 x. So here we have some more examples. So let's take a look at example 3 and 4. These are a bit different from the previous examples. Here we have fractions. So we check to see if any number on top could cancel with any number below. In this case, it cannot. 2 cannot go into 3 or 5 without a remainder. So we multiply the numbers across just like we would do with a normal fractions question. 1 times 2 is 2. And 5 times 3 is 15. So that's 2 over 15x or 2x over 15. Next, we have 2 over 7 multiply by negative 14 over 15. So we know that 2 cannot go into 15 or 7, so we cannot cancel this way or this way. However, 7 can go into 14, so we can cancel by saying 7 into 7, 1. 7 into 14 is 2. The minus sign is still there, so that's minus 2. So 2 multiplied by minus 2 is minus 4. So once we are finished cancelling, we multiply across. 2 by minus 2, and then 1 times 15 is 15. And we put back the x. So we can write this as minus 4 over 15x, or we can put it as minus 4x over 15. It's the same expression. So let's try some more questions. Pause the video and try these. Let's take a look at the solution now. Number 1 and number 2 is straightforward, so we will skip those for now. Let's take a look at number 3. I prefer to write this question like this. 4 multiplied by 1/4 x. This way we can easily see that the 4 is the numerator and the 4 on this side is the denominator, and these can be cancelled. So 4 into 4 is 1, 4 into 4 is 1. So that leaves us with 1 times 1 is 1. So on top is 1x or x, and below is 1. Anything divided by 1 is the same, so that will be x. Number 5 is simple. Number 6, believe we did that exact one before. Let's take a look at number 7. We can say 2 into 2 is 1, 2 into 4 is 2. Or we can multiply across first. So let's do that way I showed you first. 1/4 multiplied by 2x over 5. So we can reduce the fraction or cancel the fractions first. So we can say 2 into 2 is 1, 2 into 4 is 2. And then, now that we cannot reduce any further, we can say 1 times 1x. 1 times 1 is 1. We multiply it by x, so that will be x. All over 2 times 5 is 10. So your answer is x over 10. Let's take a look at number 8. Number 8 and number 9 is simple. So let's take a look at number 10. 113 multiplied by 26x. 13 into 13 is 1. 13 into 26 is 2. So that's 1 multiplied by 2x, which is 2x. Let's take a look at some more multiplication of algebraic terms. I will do this exercise with you and a few examples, and then I'll give you another exercise. Number 1, 2 multiplied by 4 is 8. So that will be 8. X multiplied by x will give you x squared. Number 2. A negative number by a positive number is a negative number. 3 multiplied by 2 is 6. And x multiplied by x squared is x cubed. Alright, let's make sure we understand that. X multiplied by x squared is simply x times x. So since we have x being multiplied by itself 3 times, that will give you x cubed. Or in other words, if we have the same base, meaning both of them has x, we can add the indices. 1 plus 2 is equal to 3. So that's x to the power of 3. Right? Similarly, for number 3, y cubed multiplied by y squared, we add, since the base is the same, y and y, we can simply add 3 plus 2 is equal to 5. So that will give you y to the power of 5. So let's start with the signs and the numbers. A negative number by a positive number, if no sign is given, a positive is understood, that will give you a negative number. And then 2/5 of 40. 2/5 multiplied by 40. So let's work that out here. 2/5 of 40. 5 into 5 is 1. 5 into 40 is 8. 2 times 8 is 16. And the letters, as we said, y cubed times y squared is y 5. Number 4, negative 3 times negative 3 is, a negative by a negative is a positive. 3 times 3 is 9. And then we have b times b is b squared. Number 5, positive 15 times positive 1, that will be 15. Y squared times y is y cubed. Number 6. So I would write this a bit different. 3m multiply by 4m over 3. That way we can see how we can cancel. 3 into 3 is 1. 3 into 3 is 1. So we can cancel. We can find one number that can divide the numerator and denominator. So now we have 1 times 4m, which is 4m. Sorry, I forgot this other m here. So it's 1m times 4m is 4m squared. Next, number 7, we have minus 20 multiplied by 4. That will give you negative 80. Z times z cubed is z to the power of 4. So let's work these numbers first. Quarter multiplied by 1/8. That will be 4 times 8 is 32. So your denominator is 32. And the letters, a squared multiplied by a is a cubed. This is the numerator and this is the numerator. So your numerator is a cubed. In this question, this looks like the denominator, but it's really the numerator. Number 9. Negative 5 multiplied by 1, that will give you negative 5. P4 multiplied by P6 is equal to P10. Negative 3 multiplied by 4 is negative 12. Q5 multiplied by Q is Q6. So you can feel free to take these down now. Then we will do a few examples and then you will try some questions on your own. Right, let's take a look at these examples. So these examples are similar to what we did before. So you all can take a look at them and take them down. 6 times 4 is 24. X squared by x is x cubed. And we put back the y. 4 by minus 2 is minus 8. A times a cubed is a4. And b squared by b cubed is b5. Right, this one, hopefully the only thing that gave you all trouble is the fractions, which is not too difficult. Minus 2/3 multiplied by 9. So 3 into 3 is 1. 3 into 9 is 3. So minus 2 by 3 is minus 6. And then we have m cubed by m squared is m5. N by n squared is n cubed. And then p squared. So once you are finished with these, we will try some questions on our own. Let's go. Right, try these questions. For now, you all can leave out the ones with the negative sign. We will do that later on. So that's, leave out this one, and this one. Leave out this one. Leave out these. Right, so now that you all are finished, we will take a look at the solution. Okay, so the solution isn't there, so let's create the solutions. So what I will do is I will erase the ones that I don't want you all to do as yet. That way we will create some space. What happened there? Okay, let's see if we have enough space now. Number 1. Negative 3 by 2 is negative 6. X times x is x squared. Y times y is y squared. So afterwards, I will leave the answers up for you to correct. Number 2. Positive 4 by negative 1 is negative 4. X squared by x is x cubed. And y cubed by y is y 4. Number 3. 5 times 2 is 10. A4 times a squared will give you a6. And b times b squared is b cubed. Next, so what I will do is I will shift this down. So 4 into 4 is 1, 4 into 16 is 4. So let's work with the numbers first. So that's negative 4. M squared by m is m cubed. And n by n squared is n cubed. Right? So 1 times negative 4 is negative 4. Next we have 3/5. So let's express this as a fraction where the numerator is above the line. Easier to work. 5 into 5 is 1. 5 into 15 is 3. So now we have 3 times 3. So that's 9. Let's make some more space for this question. So 3 times 3 is 9. X cubed by x is x4. And y by y squared is y cubed. Next, 1/8 multiplied by 4. So that will give us 4 into 4 is 1. 4 into 8 is 2. So your denominator is 2. So that's a half x cubed y squared. So notice how we go in alphabetical order, x, y. Number 11. Three into 3 is 1. 3 into 3 is 1. So your answer is a cubed times a, which is a4. B squared times b4 is b6. So that's your answer. And last, well, no, we have 2 more. So we can see that we have 5 into 5 is 1. 5 into 15 is 3. So that's negative 3 m cubed n 4. And lastly, we have 3 into 3 is 1. We know that 3 25s make 75. So 3 into 75 is 25. And we know that a negative multiplied by a negative is a positive. So that's 4 times 25 is 100. So that's positive 100. X to the power of 4. Y to the power of 5. So I hope that you all got this correct. If not, make your corrections. Division of algebraic terms. So let's do a few examples and then you all can do the exercise on the right. Number 1, 8x divided by 2. So we can write this as a fraction if we prefer. So let's do that. 8x divided by 2, we can write that as 8x over 2. That way we can cancel. 2 into 2 is 1, 2 into 8 is 4. So the answer is 4x. Next, we have 12x divided by 2x. So 12 divided by 2, of course, is 6. So again, we can write it like this if we want to. 2 into 2 is 1, 2 into 12 is 6. So your answer is, oh, we didn't put the x below. That's my mistake. So let's do that now. 1x on top will cancel with 1x below. So your answer is 6. Divided by 1 is 6. Number 3. 15x squared divided by x. So we don't have a number below that can go into 15 to reduce 15. What we can do is cancel 1x on top with 1x below. X squared simply means x times x. So if we divide that by x, one of the x's on top will cancel one of the x's below. Or we can write it like this. Cancel one below with 1 on top. So your answer is 15x. Number 4. Seven into 7 is 1. 7 into 21 is 3. A negative number divided by a positive number will give you a negative number. So that's negative 3. And 2 y's will cancel with 2 of these y's, leaving you 1. So that's negative 3y. Number 5. So a negative divided by a negative will give you a positive. 5 into 5 is 1. 5 into 20 is 4. So that's positive 4. One of the a's will cancel with one of the a's on top, leaving you with a. And one of the b on top will cancel with one of the b's below, leaving you with b below. So the answer is 4a over b. So you all can take down the examples and then try the questions. When you are finished, you can unpause the video and we will go through the solutions. Okay, let's correct. 18 divided by 3 is 6, so that's 6a. 16 divided by 2 is 8. If we divide, we will get one of the b's on top cancelling one of the b's below. Number 3, 25c cubed divided by 5c. 5 into 5 is 1, 5 into 25, 5, c into c, or rather cancel 1c below with 1c on top, that will leave you with c squared. So the answer is 5c squared. Number 4, so a negative number divided by a positive number will give you a negative number. 9 into 9 is 1, 9 into 27 is 3. And 2 of the d's will cancel with 2 out of the 5 d's, leaving you with d cubed. And lastly, we have this here, so let's do that. A positive number divided by a negative number is a negative number. Six into 6 is 1, 6 into 24 is 4. One of the q's will cancel with one of the q's, so that will leave you with q squared. Two of the p's will cancel with two of the p's, leaving you with p squared below. Pause the video and check your answers. Here we have some more examples. These are written in a fraction form. So you can pause the video now and attempt these questions. These should be easy. Okay, now to the answers. And moving on. Here we have a few more examples. These are similar to what we did before. You all can take these down. And now let's try some more questions. So once you all have finished these, we will correct them. Let's do that now. So we don't have the answers for all of them. Okay, we have some. Next. Again, all of these are similar to what we did at the beginning. So you all can take these down to get further help. And then let's try some more questions. Once you all are finished attempting these, we can correct. Let's do that now. Expanding brackets. The distributive law. This law tells us that if we add all the numbers in the brackets and then multiply it by a number, then we get the same answer as if we multiply the number directly outside of the bracket by each number inside the bracket, and then found the sum of each number or term. So we will illustrate this now. So if we have an example here, 5 multiply by 1 plus 3. So we can do that two ways. We can say, well, 5, we can add what's inside the bracket. 1 plus 3 is 4. So we can say 5 multiplied by 4 is 20. Or we can multiply 5 by each term in the bracket. So we can say 5 times 1 is 5 plus 5 times 3 is 15. And we will also get 20. So you can pause the video now, take down this definition and example. Let's continue. So here we have 3 other examples. Well, actually 5. So 10 times A is 10A plus 10 times B is 10B. Minus 5 by Y is minus 5Y. In negative by a positive is a negative. 5 by Z is 5Z. So that's negative 5Z or minus 5Z. C. A negative by a negative is a positive. 6 by 2 is 12. So that's positive 12A. Negative by positive is negative. 6 by 3 is 18. So that's minus 18B. So this is minus 4A minus 4B plus 2A plus 4. There should be 4B. Yes. Right, so what we can do next is group the like terms. So we have minus 4a and we have plus 2a. So that's this here. And then we have minus 4b plus 4b. Right, so we will get minus 4 plus 2 is minus 2. So that's minus 2a. And here, minus 4 plus 4 is 0. So that's 0b or 0. So your answer is negative 2a. And lastly, so you can try this one. And then check the answer. Okay, let's continue. So here we have 4 examples. So we'll look at example 3 and example 4 as these involve fractions. One third of y plus z. So we will multiply 1/3 by y and then 1/3 by z. So 1/3 of y is simply y over 3, or we can say 1 times y over 3 times 1 plus z over 3. Right, 1 times z is z and 3 times 1 is 3. And next, let's look at number 4. So we can say 2 into 4. Well, let's not do it like that. Let's do it in 2 parts. 4 by x over 6 minus 4 by minus 3y over 2. Two into 4 is 2. 2 into 6 is 3. So that's 2x over 3. And here we have 2 into 2 is 1. 2 into 4 is 2. A negative by a negative is a positive. So that's 2 multiplied by 3. That's 6y over 1 or 6y. Wait, I made a mistake with a negative sign. So this is supposed to be plus here, and this is supposed to be minus. So you can pause the video and you can take down these examples. So now let's try an exercise. Okay, so let's take a look at the answers. Okay, moving on. So here we have some more examples where we are not simply just multiplying by a constant, meaning we are not simply multiplying by a whole number. Instead, we are multiplying by a whole number and an algebraic term. So, for example, x. So let's go through one of these examples. So 3 times 4 is 12. A times a is a squared. 3 times negative 5 is negative 15. So that's negative 15a. Right, and the other examples are similar. So when you are finished taking these down, we will try some questions. Okay, let's try an exercise. Let's correct. Here we have expanding brackets with algebraic fractions. Let's go through these examples together. X squared by x will give you x cubed. So that's x cubed over 2. And x squared by 1 will give you x squared. So that's x squared over 3. Number 2. So we are going to multiply the term directly outside by each term. So let's start with this. y4 times y squared give you y6 over 4, and that's because y times 1 is, 4 times 1 is 4. And then we have positive by negative is negative. y4 times xy would be x y5, and 4 times 2 is 8. Number 3, we have minus a over 8 by 16b squared minus a over 4. Minus a over 8 multiplied by 16b squared, and then we have, well, a negative by a negative is a positive, right? So that's positive a over 8 multiplied by a over 4. So let's work this out. 8 into 8 is 1, 8 into 16 is 2. So that's negative or minus 2ab squared. Minus 2ab squared. And next we have a times a is a squared all over a times 4 is 32. And by the last one, I'll leave you to do the last one on your own, and then you can check the answer. So once you have taken this down, we will try some questions. Let's continue. That's correct. Moving along. So here we have expanding brackets where we are multiplying one bracket by another bracket, and each of the brackets have two terms in it. So let's do example 1, but I will elaborate on the working. So what we will do is we will multiply the first term in the first bracket by the first term by the second term by the first term, and the second term by the second term. So we will color code this to make it easier to follow. First term by the first term, first term by the second term by the first term and second term by the second term. So let's begin. So we will use, of course, red for this, followed by purple for this, blue for this, and green for this. Five A times 3B. Followed by 5A by minus 2A. So what I did for this one is I multiplied positive by negative to give you a negative, and then I multiplied the numbers. Then we will go with the second term by the first term. So that's positive by positive is positive. And lastly, second term by second term, positive by negative is negative. Five times 3 is 15. That's 15AB, followed by minus 5 by 2 is 10, so that's minus 10, and A by A is A squared, followed by 7 3s at 21, so that's 21B, and minus 7 2s are 14, so that's 14A. And that is your answer. And we can compare this to this answer here, which is identical. So if you have colored pens, you can do this example like this so that you can understand a bit clearer. And then I think the other example should be easy to follow once you understand this one. So you can go ahead and try all of the examples or take down all of the examples. Right, so the name for this type is called quadratic expressions, but we will learn more about that later on. Right, so now that you have finished taking these down, let's continue. So here we have an exercise, so you can pause the video now and try these questions. All right, let's correct. So these are straightforward, so I won't go through them in detail. Instead, you can compare your answers and make your corrections. All right, let's continue. Okay, so let's look at expanding the brackets where we have a square or squaring of the brackets. So this simply means a plus b squared simply means a plus b multiplied by a plus b. Square simply means multiply by itself. Right, and we already know how to do that, so you can easily understand examples 1 to 4. So take these down and we will try some questions. Right, let's continue. Okay, so go ahead and try as much as you like, and then we will go to the solutions. Let's continue. Now that we got this, let's move along. Right, so these, we will notice something unique about these, so let's go through one of them. A plus B by A minus B. So the first thing that we can notice is that the terms are the same in both brackets, but the signs are different in the middle, particularly in the middle. So let's multiply this. A times A is A squared. A times minus B is minus AB. B times A is AB. And B times minus B is minus B squared. So what we can notice with this is that we have A squared, which is the first term squared. We have minus AB plus AB, so they will cancel out each other. Minus 1 plus 1 is 0. And then we have the second term is squared. So that's A squared minus B squared. The first term squared minus the second term squared. And you will notice that for all of them. So take down the examples and then we will try some questions. Let's try a few. Let's correct. Factorization of algebraic terms. Let's review factors. What is a factor? If a number is divisible by another number, then that divisor is a factor. So this is a good definition for whole numbers. So let's look at the factors. This is some simple revision. Let's look at the factors of 12. So what are the numbers that 12 can be divided by without giving a remainder? So we know that 12 can be divided by 1. So 1 into 12 is 12, so that's a factor. 2 into 12 is 6, so 2 is a factor. 3 into 12 is 4, so 3 is a factor. 4 into 12 is 3, so 4 is a factor. 5 will give you a remainder, so that's not 1. 6 into 12 is 2, so 6 is a factor. And the last factor is 12. So 1 and the number is always a factor of the number. So now if I ask you to find the LCM, which is the lowest common, HCF, the highest common factor of 12 and 18, how would you do that? Well, we can list the factors for 12 and 18, and then we can choose the highest one. So the factors of 18 will be 1, 2, 3, 6, 9, and 18. So the common factors will be 1, 2, 3, 6. So the highest common factor will be 6. So your answer is 6. Okay, so that's simple for whole numbers. What about algebraic terms? How can we find the highest common factor for algebraic terms? So let's take a look. If we have something such as y cubed, what will be the factors of y cubed? Well, what can go into y cubed? So let's expound on y cubed. Y cubed simply means y times y times y. So what can go into y? Well, 1, but that definitely won't be the highest common factor. What else? Y can go into y cubed because we can cancel y into y is 1, y into y is 1. So that leaves you with y squared. We can also use y squared as a factor. Y squared is y times y. So 2 of the y's will cancel with 2 of the y's, leaving you with 1 of the y's. So that is a factor. And then lastly, we can use y cubed. Y cubed can go into y cubed. Y cubed, of course, is y times y times y. And 3 of these will cancel with 3 of these. Right, so those are your factors of y cubed. Your factors will be y, y squared, and y cubed. What about y squared? Y squared will be y can go into y squared, and y squared can go into y squared. So if I ask you what is the highest common factor for these two numbers, let's put a question here. HCF of y squared and y cubed, that will be this here. Y squared can go into both of them. Y cubed will not be able to go into this because it's bigger. Just like 8 cannot go into 4. Right? The factors of a number cannot be bigger than a number. Right, so now that we understand this a little bit better, this was mostly revision. Now we can go ahead to an example. So let's take a look at example 1. So we can do these questions in 2 parts. We can look at the whole numbers, find the factor for the whole numbers, and then find the factor for the letters. So what can go into both 4 and 8 without a remainder? 4. 4 into 4, 1. 4 into 8 is 2. So that's your first step. Look for common factors and coefficients. This will be your coefficient or your whole number. Next, well, I guess it don't have to be a whole number. It can also be a fraction in this case. Next, we have find HCF of the variables. So AX and AB. So what can go into both AX and AB? That will be A, because we can divide AX by A and get X. We can divide AB by A and get B. So A can go into both of them. So now we combine them or we multiply them to get the HCF of both the numbers and the algebraic terms. So 4A. Then we want to get back this expression. How do we get the original expression? Given we have the factor, we have to get this expression back, where we will open our brackets and multiply this by something inside here. So let's see how we will do that. Divide each term by the HCF above. So we were given 4AX plus 8AB. So we divide 4AX by 4AX by 4A. Right, 4AX divided by 4A. We can say 4 into 4 is 1. 4 into 4 is 1. A into A is 1. A into A is 1. So we will remain with x for the first term. And then we have 8ab divided by, again, the same factor, 4a. 4 into 4 is 1. 4 into 8 is 2. A into A is 1. A into A is 1. So your answer is 2b. Right, so x plus 2b would go in your bracket. And how would you know if you got it correct? You can simply expand the bracket and you're supposed to get the original expression. So let's see. 8a multiplied by x, that will be 8ax. And 8a multiplied by 2, or let's say 8 multiplied by 2 is 16. Right, so I think I didn't change this last line. Yes, that is correct. So, right, I changed this here. So let me put 4. Right, so let's redo this. 4a multiplied by x, that will be 4ax. And 4a multiplied by 2b, that will be 4 times 2 is 8. And a times b is ab. So notice that we got the same answer that we started with. So we are just expressing these in two different forms. This is the same as this. Okay, good. So let's continue. So here we have 3 more examples. So you can pause the video here, take down this example, right? You can do the same for this. Pause the video here and take down these examples. If you understand what's on the left, you can stop here, or if it is you need to write down the further explanation on the right, you can do that if you prefer. Okay, let's continue. Actually, let's take a look at question 3, example 3 and example 4. Let's make sure that you all understand. So this first part is simple. What can go into 4 and 6? That's 2. What can go into a and a squared? Well, I explained that earlier. Hopefully all you understood. So a, the factors of a will be 1 and a, but we won't use 1 because anything divided by 1 will just give you back itself. That will definitely not be the highest factor in most cases. So let's just put a. A can go into a into a is 1. What are your factors of a squared? A can go into a squared and a squared can go into a squared. So if we had to circle the highest common factor, that would be a. A can go into both a and a squared. So we put that here as your factor. And then we want to get back this expression by simply multiplying this by what's inside the bracket. 2a multiplied by 2, that will give you 4a, so that's good. And 2a multiplied by what will give you this? 2a multiplied by 3. 2 multiplied by 3 will give you 6. And a multiplied by a will give you a squared. So this is your answer. Right, so now you should be able to do or understand example 4 as well. Alright, so let's continue. We continue as soon as you take this down. Okay, let's go. So here we have a few questions that we can try. These might be a little bit advanced. So let's go. So let's try these. Right, pause the video and attempt these. Alright, now that you all are finished, we can correct. Let's take a look at number 2. So here we can see that we don't have a factor for the numbers. We don't have any number other than 1 that can go into 2 and 3, and that's fine. Alright, so keep that in mind. So we'll just put the letters. A can go into both of these, so your factor will be A. And then we multiply by minus 2 to get back minus 2, and then the B. Here are some more questions. You can pause the video and attempt these. And now to the answers. Moving along. Right, so now we have factorization by grouping. So we are simply going to, normally for factorization by grouping, you'll have 4 terms. 1, 2, 3, 4. You would normally group 2 terms together, like terms, and then you'll group the other 2 like terms together. So let's see if we can find some similarity with these terms. So if we look at this term and this term, we will see that 2 can go into both of these, and A can go into both of these. Similarly, 3 can go into these 2 numbers, and X can go into these 2 terms. So we are going to bring this across to here, right, so that we can group them. That's how we group them. And we bring these together. Then we can factorize. It's easier to factorize that way. So what can go into 2 and 4? 2. What can go into A, B, and AC? A. So your factor is 2A, and then we must get back this expression. So 2A multiplied by 2A multiplied by B will give you this, and 2 multiplied by 2 will give you 4, and A multiplied by C will give you AC. So we do the same for the next 2 terms. 3 can go into 3 and 6, so that's your factor. And X can go into X, Y, and XZ. 3X multiplied by Y will give you 3XY. 3X multiplied by 2Z will give you 6XZ. So example 2 is similar, so you can pause the video and take this down. So remember, this is factorization by grouping. So let's try this exercise, factorization by grouping. So factorize the following. When you all are finished, you can unpause the video and we will go through the answers together. Alright, let's correct. So for number 1, we can see this term has multiples of 4 and a factor of q. So we will group those together. 4pq plus 8qr and likewise 3xy and 12xc has common factors. Alright, 3 can go into both 3 and 12, and x can go into both xy and xc. So let's factorize now that we have finished grouping. What can go into both 4 and 8? That's 4. What can go into both PQ and QR? That will be Q. And now we want to get back to original expression. So that will be 4Q multiplied by P plus 4 times 2 will give you 8. And Q times R will give you QR. So R will be here. Plus 3 can go into both 3 and 12. X can go into both X, Y, and XC. So we can multiply this by Y to get back the original expression. 3 times 4 will give you 12. Right, so if you all had any trouble with that, you all can check back the other questions that you all did and retry them or fix them. So let's take a look at the answers for the other questions. Make any necessary corrections and then we can move on. The difference of two squares. So we have two square terms, and this shows us that the first term plus the second term multiplied by the first term subtract the second term will give you this expression. So these two expressions are the same. So let's try that. A plus B multiplied by A minus B. So let's expand these brackets and see if we get what they showed us before, which is A squared minus B squared. Let's see if we can get that. So as we know from doing expanding brackets, we know we would multiply the first term by the first term, and then the first term by the second term, the second term by the first term, and then the second term by the second term. So let's do that. A multiplied by A is A squared. A multiplied by minus B is minus AB. And B multiplied by A is AB, and B multiplied by minus B is minus B squared. So is there any like terms that we can add or subtract? Yes. Minus AB plus AB, or we can say AB minus AB will give you 0, right? That comes like minus 1 plus 1 is 0. So we're going to put back the a squared. These two will cancel out each other. Minus b squared. So we did get the difference of two squares. Right, so you can take these down and try, well, you'll have some examples to take down as well. And then we'll see if we have some questions afterwards. So now that we have understood the proof, let's take a look at some examples. So we will skip example 1 because that's almost identical to what we just did. So let's take a look at example 2. M squared minus 4. Now, really what we're going to have here is two brackets. Right? One bracket will have an addition sign, and the second one will have a subtraction sign. So the first term will be the square root of the first term, and the second term will be the square root of the second term. Alright, so what's the square root of m squared? That will be m. And what is the square root of 4? That will be 2. Right, so we know that two terms are m and 2. Right, just like we had on top, square root of a squared is a, and the square root of, let's take it here, square root of a squared is a, and the square root of b squared is b. So we put back those terms, an addition sign between one and a subtraction sign between one. Simple as that. So the difference of two squares, you find the square root, that's one term, square root, that's the second term. Let's take a look at example 4. 4p squared minus 16q squared. Right, so again, the difference of two squares. So the algebraic term is a square term, and the numbers are square numbers. So that's how we would know we can use this rule, right? So we're going to have two brackets, and we're going to have an addition sign between the square root and a subtraction sign between the square of the terms. Alright, so square root of 4 is 2, square root of p squared is p, so that's 2p. Square root of 16 is 4, and this is q. That's 4q. Right, 2p, 4q. So if that helps you, you can take it down like that. You can add that to your explanation. Alright, so once you all are finished taking on the examples, we'll move to some questions. Let's go. Try these, please. That's correct.
Thank you for watching. If you have found this video to be helpful, please feel free to contact us for more information about our classes.